Okay, well, let's get started. Thanks everyone for coming over and taking some time out of your day to chat with me and Harry and everybody else. I hope you've been able to tune into some of these little chats. Just an opportunity to, I don't know, talk to some adults for a little bit, take a break from so much work. Although it is lovely here in DC today, so hopefully you all have a chance to go outside. So I'm really excited to have Harry Stevens join us today. As you probably know, likely know since you're here, Harry created this incredible piece at the Post that I'm going to put in on simulating the infections rate, essentially. And so Harry actually has a hard out today at 2:30, so we'll basically do half an hour with Harry, and then I'm happy to continue if people just want to talk for a little bit. We'll just go to 3. But I thought, Harry, you could just tell folks a little bit about yourself, because you've been in a couple other places that I think folks would be interested in. And maybe just give us a little behind the scenes about that piece, and then your reaction to what happened when it kind of took off and President Obama tweeted it out. Like, that's got to be a pretty like warm, tingly feeling that day. So let me just hand it over to you and tell us what's going on.
All right. Well, thanks for having me, John, and it's good to be here. Hi, everybody. So, like John said, my name's Harry Stevens. I work for the Washington Post. I'm on the graphics team there. Before this, I was at Axios, where I did graphics, news graphics, and before that, I was at the Hindustan Times in New Delhi, India, where I also did news graphics. Before that, I was more of a print reporter, so I didn't do the graphics thing. I was a crime reporter at the Salt Lake Tribune for a little while, so I did the sort of reporting and journalism side of things before I did the graphics side of things. But for the past, 5 years or so, I've been doing graphics, full time, all the time, and really love it. I just think it's fun to experiment with new visual forms, and I think it's a really powerful way to communicate with people. You can communicate a lot of information all at once, and it sort of opens up avenues for storytelling that are not there if you are only able to communicate with words. So something that I've really enjoyed doing and hope to continue to do for a long time. So with regard to the story that Barack Obama tweeted, among other people, John, that was a crazy experience. Although at the time, I have to say I had kind of mixed feelings about it, because there's this journalism cliche that you're only as good as your last story. So now it's every time I don't get Obama to tweet something, my editors are going to wonder, what's going on.
Nowhere to go but down from here, right?
It's true. I don't know. It's going to be hard to tell. We'll see. I was thinking if I could get LeBron James to tweet something, that would really be for me the best.
That's it. That's moving up. All right. So all you have to do is just change the visuals in that piece from little dots to little basketballs.
Yeah. I don't know why I didn't think of that. So yeah, I mean, the story behind this piece, it did a lot better in terms of reach and traffic than anything that I ever could have imagined or anticipated. But I mean, basically the idea behind it came from two separate places. One was that that week that I was working on it, there'd been a lot of people tweeting and talking about this idea of flattening the curve, so that if you don't do any social distancing or adopt any measures to reduce the rate of infection of COVID-19, that you'll just have this runaway exponential growth curve. And then so some people had shared graphics of if we can only encourage people to stay home or to interact with each other less, that you'll have this flattening of the curve. And then as a result, not only will you have fewer infections, but you could keep the infection rate so low such that the hospitals would be able to have enough capacity to deal with all of the sick patients. So I thought that visual by itself was pretty powerful. And then I also had been doing a lot of times, like I just code and make graphics just for fun without any kind of like idea about how it's going to become a story or anything like that. So uh, like a year ago or so, I'd been doing this thing, this experiment with like collision detection. So, you know, you imagine you have two dots. I mean, you don't have to imagine, you've seen it now, but you know, you have two dots moving around on a screen and they hit each other, like what happens? So just like figuring out what the math for that would be. Um, so like you can kind of imagine it like if you have two circles, uh, so if the distance between their centers is less than the sum of their radiuses, then they've collided, right? And then they can swap angles and sort of shoot off in another direction. So I had that going, and so we were having a meeting like we have with our editors, talking about ideas of how we could sort of move our coverage forward. And I showed that simple experiment that I'd done a year ago to my editors, and I was like, hey, maybe we could use this to kind of simulate how a disease spreads through a network when people are just bouncing off each other and making each other sick. And they thought that that could be a cool idea. So I went back to my desk and worked on it for a couple days just to get the prototype working of like the collision detection plus storing the information about the state of the simulation over time, so that not only could you see like every slice of time as the simulation progressed, but you could also see in 4 dimensions like how the state of the simulation has changed over time. And once I had that working, it was like, okay, this is going to be pretty good. We can do something with this. And then over the course of like a week or so, we refined it. Like I got a lot of feedback from editors and from other people I work with about, you know, what worked, what didn't work. And so little by little, we cut a lot of stuff and sort of settled on those 4 simulations, which we ended up using. So that's kind of the whole story of it.
So it started. So how long did the whole project take from the beginning? I mean, aside from the previous work you were doing on the collision detection, like when you actually went to your editor and said, hey, I think we could use this for a COVID related story. Like how long did that whole process take?
I think that was about like a week and a half, but I was working on
Yeah.
it, you know, as much as I could during that time because I was really afraid of not getting it out in time, you know, so like that the notion of flattening the curve would have at that point become kind of like obvious to people. So, you know, like the earlier I could get it out, I felt like the more impact it would have. So
Mm-hmm.
we were just kind of rushing to get it out, but also to make it good. So,
Yeah, you're right.
so it was a week and a half was about the right time.
Yeah, which seems really fast for a project like that.
Yeah, but fortunately, like I had the collision detection logic already written out, so that
Yeah,
if I hadn't done that already, it would have taken a lot longer.
right. So for folks who are sort of rolling in, Harry has another deadline coming up, so he needs to take off at 2:30. So if you have questions, just start dropping them in the chat window. But until I see some questions, or raise your hand or whatever, chat window is easier, I think. But I'll just keep pestering you with questions until other folks. Well, here we go. We already got one. Lauren wants to know about choosing the colors.
That's a great question. So the truth is, I think I could have done better with the colors. Uh, I always test the colors. I have this browser tool that tests them for various different types of color blindness. Um, so I did test it for color blindness, but then afterwards, I looked at it again and I was like, the red-green colorblind wasn't great. But so the important thing that I wanted to do was, for one, use different lightnesses. So like the sick dots are not only red, but they're also darker. And the healthy dots are not like, they're like kind of greenish blue, but they're also lighter. So even if you can't see the color difference, you can see the lightness difference. And then the recovered dots are like somewhere in the middle in terms of lightness. And then like we have a color palette that we choose from at the Post, just like a lot of places have their color palette, just that because they want to have some kind of consistency in their look over time. So, you know, we have a certain number of oranges and purples to choose from. And so I just kind of chose from those.
There's a bunch of questions about the programming language you used, toolkit. But I think Todd has sort of the most specific question. So I'm going to unmute him and he can ask you. He wants to know more a little bit about the code. So maybe I'll just let him ask. So Todd, here you go.
Hi, can you hear me?
Yep.
Yeah.
Hey, Todd.
Okay. I was just wondering, what language did you use, and just to talk more about the coding process itself.
Sure. So the whole thing is written in JavaScript. So basically, okay, so for the math behind the collision detection, I used a library called geometric.js, which you can find on GitHub. It's open source. It's a library that I created about beginning like a year and a half ago. So basically the idea for the library is like, there's all sorts of questions of computational geometry that you might have when you're making something in your browser. Like you want to know how far two dots are from each other in pixels, or you want to know like the angle of two dots from each other. You might want to know the area of a polygon, or any one of these sorts of basic 2D geometry questions. And you can like Google it and find the answers usually on Stack Overflow. But if you want to Google it, like you don't want to do that every time. That's kind of the idea behind a library, is you take all of the functions and you organize them and make them easy to download, and then you can just use them whenever you want. And then you don't have to remember trigonometry, which I can't do. So so it's just useful like that. And so I kind of mentioned it earlier, but basically like you create a simulation where you have, you know, n amount of points, and each point has, let's see, it has a speed, it has an angle, it has a position, and it has a radius. So it has these 4 properties. And basically like on every tick of the simulation, you move every point at a certain, so the speed is just the number of pixels you move it. The angle is the angle, and then you move it from the position that it was at, right, to the new position. And then the collision detection happens where basically you can kind of try to imagine it in your head, but so you have 2 circles. If the distance from their centers is less than the sum of their radii, right, like this, they've collided. And then so I just have them switch angles. So like they're going like this, and then they just switch angles. And that pretty much worked. Like it's not perfect, but it's not like reality exactly, but it looks good enough. And like if you really wanted, I'm thinking about writing a tutorial on this just to get a basic collision detection thing going. But like if you really wanted to go crazy with it, like so this algorithm is going to run in quadratic time, because for every tick, every dot, you have to compare it to every other dot. So it's like however many dots there are, you have to loop through them twice. And you can do things like use like a quad tree, I'm told. I've never done this before, so that you could limit the number of dots that each one has to be compared to, and you can make it faster. But for 200 dots, it was fine. And okay, so that was for the collision detection. Might be more than you wanted to know, but anyway, that's kind of how I figured that out. And then as far as the charts, so there's a chart that runs along the top, and that's with D3.js. Pretty much anytime I make a chart in JavaScript, it's with D3.js. It's a really great library for making charts. Yeah, that's about it. There's some other implementation details, but you know, there's a lot of stuff.
That's a lot. So someone had asked if you consider D3. So you use D3 for the charts, but not for the simulation itself. That's just pure JavaScript.
Yeah, for the simulation itself, it wouldn't have really made sense. There's no need for like a data join or anything like that.
Right.
And then to render it, like I just used Canvas, like the Canvas API, because all you're doing is drawing circles, so it's not
right.
too complicated.
And when they collide, you said that the angle, they go opposite. So it's not a random. So if I looked really, really closely, I would be able to see that all the collisions are essentially just doing that opposite effect.
Yeah, they just switch angles.
Yeah.
They swap their angles. And it's actually not perfect because like, so, okay, let's say you have two dots and they're coming along like this and they kind of glance off each other. You'd expect them to kind of go like that. But since they swap
Yeah.
angles, they just go back like that. So it's not realistic,
Gotcha.
but it's like all happening so fast, you don't even notice
Yeah, you don't even notice
the
it.
parts that
Right.
are.
Cool. Raul has a question about talking to specialists and experts. So I'm just going to unmute him and let him ask.
Yeah, go ahead, Raul.
Hey, hi, Harry.
Hey.
Grace from Peru, Lima.
Cool.
I want to ask you, did you talk directly to an epidemiologist or other kind of expert?
Yeah, that's a great question. And I did talk to a couple epidemiologists. So the first one that I talked to was like a while ago, because I wanted to do something where like you could actually simulate the trajectory of the real COVID-19 in the real world. And in fact, the New York Times just published something about like this today. It's kind of like a simulator where you can see the curves over time. But even in that piece, they acknowledge that like there's sort of a false precision to those forecasts because there's just so much uncertainty. There's a lot about COVID-19 that we don't know, and a lot about how many cases there have been that we don't know, and fatality rates, and so on and so forth. So I was talking to an epidemiologist about like, because I was like, I kind of wanted to make something like they did in the New York Times, where it's like, you know, you could have people adjust the parameters and see how the forecast would change. But she was like, look, I got like a team of PhDs and we all know a lot of math and we run our model on a computer overnight because it's so computationally intensive to do it. So she was kind of like, I don't think that's going to work. And then she was also like, you know, you have to be careful about representing the uncertainty in the model because you know, even after we run this thing on a computer, like the output has this wide range of uncertainty about how many cases there are going to be. So it's very, very difficult to predict the trajectory of a real disease in the real world with all of its complexity. And so that kind of turned me off of the idea of trying to do that. And that's why I ended up going with just this fake disease in a very, very simple environment. But I think that even then, even though like simulitis, as I called it, is like really different from COVID-19 in a lot of ways. Like for example, people who can't die from simulitis and they can from COVID-19, there's a bunch of different ways that they're different. And also the way that people interact in the fake town is obviously really different. Like in the real world, people don't just move at random and bounce off each other when they hit it, like, you know, that's not real. But I think that even in a very, very simple environment like that, you still end up getting the kinds of growth curves that you'd expect. So the metaphor ends up working pretty well, even though it's really simple. So like, it can't predict the future, but it does do a pretty good job of explaining how network effects work and some ways to disrupt them.
So the error margin, it's very dangerous in this case. It can be misunderstood.
I think that it's always a challenge for people doing data visualization to represent uncertainty well. Not even a concept that a lot of people are familiar with really thinking about. And you see it with like, you know, people who try to forecast election results where they're like, you know, we think Hillary Clinton's going to win, but you know, there's uncertainty and then Hillary Clinton doesn't win and everybody gets mad at the forecaster. So that kind of, I mean, think about weathermen. People are always getting angry at weathermen for getting the forecast wrong, but there's uncertainty in forecasts. And of course, with something like COVID-19, there's huge uncertainty. And that doesn't mean that you shouldn't try to forecast it. It means that I shouldn't try to forecast it because I don't have the expertise to do that.
Cool. Thank you.
Thanks for your question.
Great. Harry, we've got you for another 9 minutes. I don't see any other questions in the chat box, so I will take 100% of your precious time here. I'm curious about the decision. I mean, in hindsight, it's kind of an obvious answer, but the decision to do the animated piece versus something that was maybe more static or more an interactive, where it'd be a click and a drag or something like that. So what was your thought process about making this as a simulated piece or an animated piece? And also sort of tail end on that, this opportunity for the reader to say, simulate it again, let me see it again, as opposed to it just sort of running on a loop or something like that.
Yeah. So all those were specific decisions. Having the simulation was because simulations are fun to watch, basically. Like they draw you in a way that just seeing the chart doesn't. So like it's no accident that I made the bouncing dot simulation before I made the chart. Like I was making that without any idea of ever being able to use it to model a disease. I was just making it because it's fun to watch. So, you know, I think if you can present your reader with something that's kind of fun to look at, I mean, it can't just be frivolous, of course, but giving them something that is engaging to look at is always a plus. And then so I wanted it to autoplay. It was really important. So there's all this logic in the code to not start it until it first scrolls into the frame, and then it starts playing automatically. And the reason for that is that I wanted the reader to see it from the beginning, but I didn't want to ask them to have to click a button to have it start, because 90% of the people aren't going to click the button. So that would ruin it, right? Like it has to start playing automatically.
Right.
And then like it takes a while to run and people are watching it. If it ends, like you might want to see it again, but you might also not, right? So having that option there is really important to like let people say, click, I want to see it again. And the other thing is like, if you're watching it and it doesn't finish and then you scroll away, it'll stop. And if you scroll back, it'll start up again from where it was. And the reason for that is that otherwise you might have 4 of these simulations running in the browser all at once. And if you do that, then your computer starts to complain. Like you'll hear the fan start spinning, and it's just too much computation. So it's better to just only show what needs to be shown.
Right. In the frame when you're there.
Yeah.
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 Yeah. Interesting.
So, and I think in general, like, just like an idea for people who are making graphics, like it's always tempting to want to give the user the power to interact, but I think it's an instinct that you should try to fight, because most people don't interact, and you should never hide like functionality or meaning behind interactivity if you can avoid it. So like only use the interactivity that is absolutely necessary, and otherwise just give everything right up front, I think is a good principle.
Right. So and is that, do you think, is that a principle that the post graphics desk tries to follow, or is that a personal Harry? I mean, I know other people have talked about this, and you know, there's been lots of documentation of it, but is that more of a, is that a Washington Post graphics desk strategy, or is that a Harry Stevens strategy?
I think I don't know if it's a post graphics desk strategy. It's definitely one of my strategies. Like, there's this, like, so if you think about it, really the only natural interaction with a browser is scrolling. Everybody knows how to scroll. You know, my grandfather knows how to scroll in a browser, but he doesn't necessarily know how to use a slider or to use a drop-down menu, or he's not going to know which buttons to click. He doesn't know about tooltips. Like there's all kinds of interactivity that he's not going to be able to do, but scrolling he does. So that's why a lot of times, like me and a lot of other people will put interactivity behind a scroll, so that like as you scroll, the story advances. Now that didn't end up working for this piece. I tried a version with like scrollytelling, as it's called. It didn't work because on a mobile device, there's just not enough space. So you end up having like text on top of the graphic. And when it's a simulation, like you want people looking at the simulation, not being confused about whether they should look at the text or look at the simulation. But so anyway, that's the reason why people use scrolling. And it's a reason that like I would use scrolling, or I would just try to avoid forcing people to do any kind of interactivity that I could just give to them right away. But then like you can give a little bit of interactivity, right? So like I had the clicking the button, and I think like to replay. And I think that if I had more time to make it, I might have even made like a simulation sandbox at the end where like you could set up your own parameters. Like I want this many people moving, and I want, you could even imagine like I want people to be able to wash their hands so that the transmission rate reduces, or I want to draw my own quarantine boundaries or whatever. I just didn't have time to do that, but I think that would be cool. And I think you can introduce that kind of interactivity afterwards, after you show people how the thing works without interactivity.
Right. So Kyle just put in a question. I'll just read it real quick since you have to go in a moment. Is there a reason to make it real time versus recorded as a pre-run simulation?
Yeah, definitely. I think that the randomness brings a sort of fun and interesting quality to it. Like every time you read the story, it's going to be a little bit different. I also think it adds credibility to it because it's like, I didn't set this up in advance. Like all I did was create the parameters and then you let it run, but the results are kind of the same every time, which sort of, lends credibility to the idea that like these strategies actually do produce different results. It's not like I'm like rigging it.
Yeah. Let me ask this last question. I think this is the last question. You've been doing this for a while, from the Hindustan Times to Axios and now at the Post. And so back to this idea of not making people do things that may not be a natural way to interact with the web. Anecdotally, I feel like there's been a move. There was a big move towards interactivity for a while. Like right when D3 came out, everything was interactive, and now we've moved pretty far away from that. Is that something that you think has happened too, that we're moving away from the interactivity?
Yeah, I think so. I mean, I think that interactivity can be really great in certain environments. Like, for example, if you're making a dashboard that somebody is going to use every day, or some software that someone's going to use every day, they can learn the user interface, and they will take the time to learn the user interface. But in a journalistic environment where people are going to read the article one time, like you don't want them to have to learn new things. Like you want them to be able to leverage the knowledge that they already have to quickly understand what you're showing them. Right. So I think that, in general, like there's been a movement towards less interactivity and more simplicity. Also, the other thing is like, we got to churn stories out quickly, and building interactive things takes time. It takes more time. So.
Right. Well, very good. I'm going to let you go. I know you have a meeting. Thanks for coming on and telling us all about it. Congrats on its success. It was really great. And we're just all like waiting for your next big piece.
Oh yeah, it's going to be tough. Obama's waiting too.
I'm sure he is. Yeah. All right. I'm going to let you go. Thanks a lot. Other folks, if you want to head out, thanks, Harry. If you want to head out, that's great. If you want to hang out and just chat for a little bit, I'm happy to do that too. Just a reminder that Echo Rivera, who's in the presentation field, will be here tomorrow to chat. This is tomorrow late afternoon. I'm trying to move things around over the course of the day, so I try to hit multiple time zones and what have you. And then next week, I've already got the schedule set up. So I'll give you the sneak preview if you want. Graham McDonald and Claire Bowen from the Urban Institute will be here on Monday. On Tuesday, my colleagues Rob Santos and Diana Elliott, who have a really cool piece on the census, will be chatting with us. On Wednesday, Manuel Lima, who's written 2 books, one on circles and one on trees, will be chatting. On Thursday, it will be Lisa Charlotte Roast and Gregor Eisch from Data Wrapper will be chatting with us. And then on Friday, it'll be Enrico Bertini and Moritz Steffener from, among other things, from Data Stories podcast. So that's who's set to come next week. So I've got a full week with various times to help people around the world join us. And I am recording all of these, so they all will be up as soon as we can get them going. So happy to just chat for another 30 minutes. I have no agenda for these, so feel free to raise your hand or unmute yourself and ask a general or specific question, and we can chat about it. There's a lot of people in here who have done a lot of different kinds of work, so happy to just have a discussion if anybody wants to chat. Okay, well, I guess everybody's gonna stay quiet and just hang out in their apartments and homes. My mom's there waving. So, okay. That's great. This is terrific. Thanks everyone for tuning in. Yeah, have a great Thursday afternoon. And hopefully I'll see you all at some point soon. So stay safe, stay healthy. Thanks a lot, everybody. Talk to you soon. Bye. Bye, Mom.